My name is Nick, and I'm here to present the solution to problem L, splitting pairs. In this problem, Alice and Bob are playing a variant of NIM. Given n piles of stones, the current player will pick at most half of them and remove them. Then they'll pick k other piles each with at least 2 stones, and then split them into 2 non-empty piles. The player who cannot move loses. Determine who wins given optimal play. In this problem, there are at most 50 piles, and each pile contains at most 1 trillion stones. We can make some observations. So for example, the only losing configuration is when all piles have exactly 1 stone. When n is even, we can do some case analysis and see that a state seems to be winning if and only if at least one pile has an even number of stones. When n is odd, it gets more complicated. But if we divide all values by the largest power of 2 that divides all of them, then we seem to run into something similar, where the state is losing if and only if all piles have an odd number of stones after the reduction. It turns out that these are necessary and sufficient conditions. We'll quickly go over the proofs for why this is the case. In the even n case, if all piles have an odd number of stones, then it's impossible to only have odd stones after one move. But if there are an even number of stones in some pile, then there are some constructions based on how many piles have that. In the odd n case, we have something similar, where if there is some power of 2 such that all of the piles are divisible by that power of 2, but then some of them are divisible by the power of 2 larger, we can use the same logic to do some splitting to get into the losing state.